Hello! Just going to try and explain a really big topic to you now. So this is straight line graphs. We're going to talk about gradients, we're going to talk about y-intercepts, and we're going to talk about the equation of a straight line. This thing here, y equals 2x minus 4, is an equation of a straight line. So I'm going to try and talk you through this big topic, lot to get through. Do pause this video as you're going along at any time you think I didn't understand it. So take this, pause it when you need to, and just recap what I'm doing. Okay, so this is a formula or an equation of a straight line, and we can use that equation to generate a table of values or coordinates, and then we can plot those coordinates in a graph. So this equation has a table and a graph. Now here we've drawn up the table, so we're going to just pick some points for x, some values for x, from -1, 0, 1, 2, 3. Those are just, we can pick any values there, but probably useful to go from a negative 0, 1, 2, 3. That's a nice set to choose. And to generate some points, what we do is we say the y coordinate equals the x coordinate times 2 minus 4. So for every one of these, if I want to generate some points, the relationship is that the y coordinate is the x coordinate times 2 take away 4. So let's plot some values in this table, shall we? Now, if you think you know what you're doing, pause the video here, write down on your paper what you think goes in there. If you're not sure, go through the first one. Let's see. So the first one here, when x is -1, y is going to be 2 times the x. So 2 times -1, then take away 4. Well, 2 times -1, 2 times -1 is -2. Then -2 minus 4 is -6. So let's just go through that again. The y coordinate is 2 lots of the x, then take away 4. 2 times -1, -2. Take away 4, -6. So now we have a coordinate for x and y. The x is -1, the y is -6. And we know coordinates are written the x value first, then the y value. So that is a point on a graph. And we can do that for all of these to generate a set of points, set of coordinates for the graph y equals 2x minus 4. We take this, times it by 2, then take away 4. Times 2, 1 times 2 is 2, take away 4 is -2. 2 times 2 is 4, take away 4 is 0. 3 times 2 is 6, take away 4 is -2. And so we get the coordinates 1 minus 6 here. 0 minus 4, 1 and -2 is that coordinate, 2, 0 is that coordinate, and 3 minus 2. Okay, that is how we generate points from an equation. Once we have those coordinates, we can plot them on a graph. Let's plot them. -1, 6, along the corridor -1, downstairs -6. That's off the bottom of the graph, down there somewhere. 0 minus 4, along 0, down 4, there it is. And we'll plot the next ones. 1 minus 2, along 1, down 2. 2, 0, along 2, up 0. 3, 2, along 3, up 2. Join them up, and that is the line y equals 2x minus 4. So that is plotting straight lines. What we can also do is from a graph find its equation, and that's one of the big things we're going to be finding out today. How do we take a graph and find out the equation? So we need a bit of vocabulary here, so take some notes on some of these keywords. The origin, where something begins. That's the English for it, where something begins. Well, a graph begins at 0, 0. The origin is always going to be the coordinate 0, 0, like that. Okay, and then we have vertical lines, and we should know that they are this way up. That's a vertical line. Horizontal lines, like the horizon. If you look out over the horizon, then you see a horizontal line. When you look at the sunset on the horizon, it's on a horizontal line. So there we go, there's a horizontal line. And here's some example equations. All vertical lines will be written x equals something. X equals minus 2, x equals minus 2, x equals minus 2, because all of those coordinates, x equals minus 2. On this one, y equals 3, because the y coordinate is always 3. This is 0, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3. The y coordinate is always 3 in this horizontal line. Okay? Just running through this very quickly now. Another bit of language, the y-intercept. Now this is really key today, so I'm just going to try and really understand what I'm saying here. Intercept means where a line crosses. So in this case, you can see there's a bit of highlights in there. I'm going to highlight it again. Where does this line cross the y-axis? Where does it cross the y-axis? Well, there's the y-axis like that. And the red line is crossing it at that point there. You can see that point there. So that, number 3 there, 0, 3, that is called the y-intercept. Where a line crosses the y-axis, the blue line. That's really important in equation of some straight lines. The y-intercept, where it crosses the y-axis. Now you can also get an x-intercept, which in this case is where it crosses the x-axis. And that is there at minus 2, 0. The one we're going to concentrate on, you can see it's highlighted there, is the y-intercept. That is even more useful for straight line graphs and finding their equation. So we have a standard form for all straight line graphs. They are written like this. Y equals, now we're using the letter m there, this is just any number. Y equals something times the x coordinate plus something. So for example, we could get y equals 2 times x plus 4. And m tells us actually I'll come to what m and c mean in a second. So here's another example. The m value here is negative 3 and the c value here is negative 7. So just recognize that we have a constant number on the end and something we multiply x by. So that's going to be m. This number in front of x is going to be m, and the one on the end is a constant. So here m is 1/5 and c is plus 6. So recognizing what's m and what's c in a straight line graph, very helpful. Now m is the gradient, how steep the line is. So m, the number in front of x, tells us how steep a line is. And then c, the constant number, is the y-intercept, where a line crosses the y-axis. Now, a bit more language here again. The number in front of x is called the coefficient of x, useful to know, and a number on its own is called a constant. Okay, let's spin on to this one, and this will be the last little bit I do, and it will be the full thing now. How do we find the equation of a line? How do we find m and c when we've got a line? Well, let's have a look at this particular example. So, here is my line. What does the minus 4 tell me? Well, the minus 4, if we remember back here, minus 4 is the number on the end, the y-intercept. And if we look at this graph, we can see it's crossing the y-axis at minus 4. So this number here tells me where the line crosses the y-axis. It tells us that the y-intercept is 0, minus 4. Okay, into gradient, slopes. And we have two different types. We have a negative slope. And what do we mean by that? Well, if I've got a man who's coming, as we read, left to right. Sorry, on your screen it'll be like that. Left to right. He's coming along, he's coming along. Is he going downhill? Yeah, he's going downhill. So because this man walking left to right is going downhill, that means this is a negative slope. Downhill. Sorry, that way. It is a negative slope. Okay. We can also have a positive slope. So if our little man is walking up the hill, he's getting higher and higher, that's a positive. He wants to get up to the top of the mountain. So it's a positive slope if it's going uphill, negative downhill. useful stuff. Loads of content in this short video. You might want to watch this 2, maybe 3 times even. Let's just have a look at the final thing, how to calculate gradient. Now, to calculate gradient, what we do is we do rise over run. Some people write that as the change in the y coordinates divided by the change in the x coordinates. Rise over run. What do we mean by that? We'll take 2 coordinates and try and pick coordinates that are exactly on a crosshair, like a crossover there. So this would be a good one because it's exactly on a cross. But these are the best ones because they're whole number coordinates. So this point and this point on the line. And I'm going to find out how much has this, going from here to here, gone up, and how much it's gone across. Up divided by across. Rise over run. We can describe it as any of these things. Change in y, change in x. So let's look. Here is my change in the y-axis. I draw this right angle triangle underneath. Now from -1 to 1, how much has it gone up? It's gone up 2. So my rise is 2 and my run is 1. And that means we have a gradient of 1. And that's all there is to it, which, you know, makes it sound simple. It is not simple. It's going to take you a bit of practice. Might be worth just pausing this, going back, recapping that. But it's rise over run. How much it's gone up divided by how much it's gone across. Up divided by across. Rise over run. Up, whoops, divided by across. So we could call it that if you like. Some people prefer that one. It's the same thing. Rise over run, up divided by cross, change in y over change in x. It's this divided by this to work out the gradient of a line. Let me give you a couple more examples. So to find the gradient, pick 2 coordinates on a line, draw a triangle underneath, and divide distance up by distance across. So let's see this one. So here's my line. I'm going to pick this coordinate and this coordinate. I'm going to say up divided by across. What do you think the gradient of this line is? What do you think? Up divided by across. 6 divided by 3 is 2. Give you another example here. And we have up divided by across. Pick this coordinate on the end. Pick this coordinate on the end. And we get 6 divided by 2 is 3. Up divided by across. Here, up divided by across, we've got 3 divided by 3, which is 1. Okay, I think that's enough examples from me now. I'm going to let you get on with the next task. If you need any help, please ask questions. This is a tricky little topic, but a really important one. And once you get it, you're going to be set for maths for a long time. All right, thanks for listening. Cheers. Bye.